Position of a point with respect to a parabola. Position of a point with respect to a parabola. Position of a point with respect to a parabola. Position of a point with respect to a parabola. Now imagine the parabola is a standard parabola, that is y square is equal to 4x, and if we take the point as x1 comma y1. So y1 square minus 4ax1 square is greater than 0. It means that the point is outside. Y1 square minus 4ax1 is equal to 0. It means that the point is on the parabola. And y1 square minus 4ax1 is less than 0. It means that the point is inside the parabola. So there are three conditions where the point is outside, point is inside, and the point is on the parabola. Okay, now if you go with this, the next thing that we understand is equation of tangent in parabola. Equation of tangent in parabola. Equation of tangent in parabola. Okay, the equation of tangent in parabola basically of three parts. सबसे पहले is Cartesian form. Cartesian form. When it is touching at a point, say x1 comma y1. Second is your parametric form. Second is your parametric form. 80 square comma 280. And last is your slope form. Y is equal to mx plus a by m. Okay, now remember this, for Cartesian form you have to remember the word where you see that you use a word at a point. Whenever we get the word at a point, whenever you use the word at a point, you can directly write it as the formula. Basically the formula is this: y square is equal to 4ax for a parabola, and it is touching at a point x1 comma y1. It is touching at a point x1 comma y1. So what I'll do is I'll write it like this: y square is equal to 2x into 2a. So y square is equal to 2a, and 2x I can write it as x plus x1, and y square I will write it as y1 is equal to 2a into x plus x1. This is the parametric form, this is the Cartesian form. Whenever you come to know about that the word is at a point, at, the answer is y1 is equal to 2a into x plus x1. Now look at the second part. Okay, look at the second part. Think of is this, ki now my point is a parameter that is 80 square comma 280. It means that in the same equation, in place of x1 I will put 80 square, and in place of y1 I will put 280. So see what will this become? Y into 280 is equal to 2 into x plus 80 square. So 280y. So what I can do is I can eliminate the 2a. So my formula is yt is equal to x plus 80 square. This is the equation of tangent in the parametric form. This is the equation of tangent in parametric form, and this is the formula for slope form. So whenever we write the Cartesian form at a point, it is y1 is equal to 2a into x plus x1. Whenever I write the parametric form, all I have done is in place of x1 I have substituted 80 square, in place of y1 I have substituted 280, so yt is equal to x plus 80 square, and the slope form is y is equal to mx plus a by m. This is y is equal to mx plus a by m. Now, since I know equation of different tangents in different forms. Now imagine if two tangents are given. Okay, so point of intersection of two tangents. Point of intersection of two tangents. Okay, point of intersection of two tangents. Well, let's consider like this. Think of it as like this. If I am drawing the point of intersection of two tangents, imagine this is the first tangent. Okay, this is the second tangent, and they are intersecting at a point P. Okay, now this is your first parameter. P 81 square comma 281. Q 82 square comma 282. So my first equation becomes yt1 is equal to x plus at1 square, and next becomes yt2 is equal to x plus at2 square. So now carefully look at the equation. Now first equation is yt1 is equal to x plus at1 square, yt2 is equal to x plus at2 square, and if I subtract them, my x term gets eliminated. If I subtract them, my x term gets eliminated. I will get y t1 minus t2 is equal to a t1 square minus t2 square. Therefore y will become a bracket t1 plus t2. Y will become a bracket t1 plus t2. Y bracket a t1 plus t2. And if I substitute, say for example I have substituted here in place of y. If I substitute in terms of y, if I substitute this value in any of the equations, so this will become, if I substitute here, so a bracket t1 plus t2 into t1 is equal to x plus a t1 square. Therefore at1 plus at2, at1 square plus at1 t2 is equal to x plus at1 square. a1 t1 square at1 square gets cancelled, so therefore my x का coordinate is at1 t2, and this is your point of intersection of two tangents, and this is my point here. This is my point here. So point is, the first point is a t1 t2, and the second point is a bracket t1 plus t2. All I have done is I have just solved both the equations simultaneously. X is at1 t2 and y is a bracket t1 plus t2. This is the point of intersection of two tangents. Now if you look carefully, okay, look at y ka and x ka value. Okay, now see this, x ka value is a t1 t2. Now carefully just look at this. I can write this as x is equal to a square t1 square t2 square the whole root. In other words, x is equal to under root of at1 into at2. Okay, because if I take the square and root, I will get at1 into at2, which is nothing but, this is nothing but the geometric mean of the x coordinates, and x coordinate is called as abscission. So this is called as the geometric mean of abscission. T1 square is root of T1 square is T1. यहाँ पे स्क्वायर है. Okay, so geometric mean of abscissa. Look at the y coordinate. Y is equal to, if you pay attention here, y is nothing but a bracket T1 plus T2. Y is equal to a bracket T1 plus T2. I can write this as y is equal to 2a T1 plus 2a T2 upon 2. If this is the geometric mean, this is called as the arithmetic mean of ordinates. So one gives you the answer for geometric mean of abscissa and second gives you the answer for arithmetic mean of the ordinates. So geometric mean of the abscissa and arithmetic mean of the ordinates. Now, if you see here, normal tangents from any point, 81 square comma 281, 82 square comma 282, tangents were drawn and ये मेरा point of intersection था. Point of intersection was yt1 is equal to x plus 81 square. This is the tangent, first tangent, second tangent, point of intersection I got x and y का value. Now it gets us thinking कि ये तो ठीक है, but what will happen? What will happen? Second point, if tangents are drawn at the end points of the focal chord, tangents are drawn from the end points of focal chord. Please try to understand this. Tangents are drawn from the end points of focal chord. So let's take an example. ये मेरा first parabola. Now I'll draw tangents from the end points of the focal chord. Okay. Let's take the tangent. ये पहले निकाल देते हैं for our understanding. Tangents are drawn from the end points of focal chord. I'll draw the first tangent. Second tangent. Now, we know that the focal chord always passes through the focus. So, I'll take this point as the focus, that is S bracket A comma 0. Now S bracket A comma 0, my P and Q, I know that 81 square comma 281. Also, I have this point of intersection. See, we just found out the point of intersection. My point of intersection is A T1 T2 and A bracket T1 plus T2. So this point will become A T1 T2 comma A bracket T1 A bracket T1 plus T2. This is your point of intersection, guys. Okay, this is the point of intersection. Now we know that the formula, we know that T1 into T2 is equal to minus 1. We know that T1 into T2 is equal to minus 1. Okay, T1 into T2 is equal to minus 1. Now since T1 into T2 becomes minus 1, T1 into T2 becomes minus 1, this coordinate, if you check, since T1 into T2 becomes minus 1, the coordinate will become A into minus 1 comma A bracket T1 minus 1 by T1. So therefore my coordinate becomes minus A comma A bracket T1 minus 1 by T1. So remember this, if it is passing and it is touching two extreme ends of the focal chord, basically tangents are drawn from the focal chord, from end points of the focal chord. So I know that the point of intersection will always lie on the directrix. Because my x coordinate is minus a, which is the equation of directrix, that is x is equal to minus a. So it will always lie on the directrix, remember this. So whenever from the extreme ends of the focal chord two tangents are drawn, the intersection of two tangents will always lie on the directrix. Remember this, the intersection on the two tangents on the focal chord will always lie on the directrix. So here what we'll do is we'll write a remark. We'll just write a remark here. Remark, tangents from the ends of focal chord, the point of intersection will lie on the directrix. So I've understood that it will lie on the directrix. Condition क्या है कि tangents are drawn on the ends of the focal chord. Point of intersection is a t1 t2 comma a bracket t1 plus t2, and we know that t1 into t2 is equal to minus 1. We've already done that. t1 into t2 is minus 1. I have just substituted t1 t2 का value minus 1, तो minus a मतलब it will lie on the directrix. And the second condition is t2 के जगह I have just substituted minus 1 by t1, and my coordinate is a bracket t1 minus 1 by t1. So these are two things. The third condition tells you कि what will happen if it's not the focal chord but it is the lattice rectum. Okay, tangents are drawn from the ends of the lattice rectum. Same condition, but tangents drawn from ends of lattice rectum. Imagine the tangents are drawn from the ends of lattice rectum. Tangents are drawn from the ends of lattice rectum. Okay. Tangents are drawn from ends of lattice rectum. Now say for example, tangents are drawn from ends of lattice rectum. Imagine this is the lattice rectum. Obviously lattice rectum also passes through the focus, but it is a lattice rectum. We know that for a parabola, lattice rectum is 4a. Length of lattice rectum is 4a. Now I know that इसका ends का भी formula पता है. It is a comma 2a and this is a comma minus 2a. Now we know that if you, I'll just write it. We know that P is what, 81 square comma 281, and Q is 82 square comma 282. Here also, see, this is P and this is Q. This is nothing but 81 square comma 281. This is nothing but 82 square comma 282. 81 square comma 281 and 82 square comma 282. If I compare them, I will get T1 is equal to 1, and if I compare them, I will get T2 is equal to 1. I have got T1 is equal to 1 and I have got T2 is equal to 1. Now, since I have got T1 is equal to 1 and T2 is equal to, this is minus 2a. Sorry, this is minus 1. Sorry guys. 282 is equal to minus 2a, so T2 is equal to minus 1. Now this satisfies this condition also, T1, T2 is equal to minus 1. And now the point of intersection here, point of intersection, look at the point of intersection. So according to this, see what the point of intersection will become. My x is nothing but a T1 T2 and my y is nothing but a bracket T1 plus T2. Guys, T1 plus T2 will become 0. So x will become minus a, y will become 0, hence my point of intersection will become a comma 0. It means that it will lie on the directrix minus a comma 0. It means that it will lie on the directrix, but it is the foot of the directrix. Matlab it will be nothing but on the x axis. It's like this. This is where it will lie, and this is your directrix, exactly here. So I'll take this point a little further. इसको minus a comma 0 ले लेंगे, and it will lie from here. Exactly डायरेक्ट्रिक्स पे लाई करेगा. Exact डायरेक्ट्रिक्स पे लाई करेगा. Foot of the directrix. So I know that. Now we have got the condition. Condition number 1, normal when it is normal intersection. Normal intersection, no condition. Point of intersection of two tangent. I got x का value, y का value. X is nothing but the geometric mean, y is nothing but the arithmetic mean. Condition number 3, end points of the focal chord. This is the condition that I got. तो मुझे ये पता चल गया कि it is passing through the directrix. But the next condition, when tangents are drawn from the end of the lattice rectum, it will be on the foot of the directrix. Basically my coordinate of the point of intersection will become minus a comma 0, because we just proved that we know that t1 into t2 is equal to minus 1, and if I compare the ends of lattice rectum, I got t1 is equal to 1, t2 is equal to minus 1. If I substitute in the main equation, I have got x ka value as minus and y ka value as 0. Okay, next. Now with parabola comes circle. Position of circle. Position of circle. अब देखो position of circle देखो क्या बोला है. Condition, and the next three conditions are very important when parabola and circle meet each other. So position of a circle. Circle made by taking end points of the focal chord. Look at this condition. Taking end points of the focal chord as the diameter. Condition by taking the end points of the focal chord as diameter. So when I make a circle, it will always, and I repeat, it will always pass through the directrix. It will basically touch the directrix. So it will be like this. Circle made by taking ends of focal chord as diameter will always touch the directrix. You have to remember this. So whenever we make this, it will always touch the directrix. It will always touch the directrix. अच्छा, touch the directrix मतलब वो directrix को touch करेगा. कहाँ पे touch करेगा अपने को आइडिया नहीं है. But it will touch the directrix. So if I make a diagram, say for example, starts with circle. Circle made by taking ends of focal chord. तो if I make a circle here, थोड़ा weird हो जाएगा circle. Imagination पे depend करना पड़ेगा अपने को. So if I make a circle and this is your directrix, the directrix also. जो directrix है यहाँ पे, ठीक है. Now if I touch it, it will become ऐसा गंदा वाला सर्कल बनेगा. इट विल टच हियर समवेयर, ऐसा कुछ तो टच करके सर्कल बनेगा. थोड़ा अजीब हो गया. सो रिमेंबर दिस सर्कल मेड बाय टेकिंग एंड्स ऑफ फोकल कॉर्ड एज अ डायमीटर विल ऑलवेज टच द डायरेक्ट्रिक्स. इट विल ऑलवेज टच द डायरेक्ट्रिक्स. अब you can draw it. This is again, as I told you, no, it's all about your imagination. So you can imagine very nicely. Okay. Now this is the focal chord. What will happen if I take my latus rectum as diameter? See, it's the same condition being repeated. So this condition mein, the circle will always touch the directrix. But this condition mein, if I make a circle here, it will touch where? At the foot of the directrix. Remember this, it will touch at the foot of the directrix. So same condition, circle made by taking ends of latus rectum as diameter will always touch at foot of the directrix. Always touch at foot of the directrix. So if I have to make this, say for example, पहले सर्कल ही बना देते हैं. ऐसा बना दिया, ऐसा बना दिया. It will यहाँ पे बना दिया foot of the directrix. This is foot of directrix. This is a parabola. Your parabola, and this is your latus rectum. ठीक है. So remember this. The tangents drawn will always touch the circle. अगर मैंने circle बनाया, थोड़ा wrong circle बन गया, but imagine कर लो. So this will always touch at the foot of the directrix. Remember this. Tangent drawn taking ends of latus rectum as diameter. थोड़ा shift होना चाहिए था. So just remember that this is the diameter. The circle थोड़ा wrong बन गया है, but just shifted on the right hand side, and I think that should be the answer. इसको वापस आना पड़ेगा. If I make parabola, let's make parabola first. This is latus rectum. is lattice rectum. This is your tangent at vertex, the axis of symmetry. It is always touch the directrix. थोड़ा और बढ़ाना चाहिए. lattice rectum. सर्कल थोड़ा बड़ा बनाना है. Yes, oval circle, guys. Enjoy. Oval circle and वो डायरेक्ट्रिक्स से टच होगा. सो रिमेंबर दिस कि अगर ऐसे बनाया मैंने तो ऐसे होगा, यहाँ पे टच होगा एंड इट विल पास थ्रू द डायरेक्ट्रिक्स. सो रिमेंबर ये ऐसा है, ऐसा है ये, and it will always ऐसा रहेगा. So this will be your diameter and it will always pass to the foot of the directrix. It's a very important concept. It will always touch the foot of the directrix. Remember this. So in other words, I can also write it as कि यहाँ पे मान जाएगा कि m1 into m2 is equal to -1 because ये है a, 2a, this is a, -2a and with respect to if I solve this, तो देखो ना इसका कोऑर्डिनेट है -a, 0. तो if I find इसका slope and if I find इसका slope, I will always get m1 into m2 is equal to -1. I will get m1 into m2 -1 because 2a plus a upon a and y2 minus y1, a minus a plus a, okay, upon x2 minus x1 and यहाँ पे y2 minus y1 upon x2 minus x1 and I will get the slope. Okay, and the last point, circle made by taking end points of semi-lattice rectum as diameter. Circle made by taking end points of semi-lattice rectum as diameter always touches the TV. TV is tangent at vertex. So remember this. ये बहुत important point है. Circle made by touching semi-lattice rectum as diameter always touches the vertex. So now for this, I have to make a diagram. ऐसे रहेगा. मेरा पैराबोला ऐसे रहेगा. सेमी लैटिस रेक्टम अगर ये है ऐसा, सेमी लैटिस रेक्टम इस डायमीटर बोला है तो ये ऐसा रहेगा बेसिकली. सर्कल विल बी लाइक दिस. दिस विल बी द सर्कल. ओके, एंड इट विल टच द वर्टेक्स, मतलब ये टच करेगा 0, a पे. दिस इज a, 2a. This will become a, 0. This is a, 0, and this point will become a, a. So these are the three important points followed by different tangents. कहाँ से निकाल सकते हैं और कैसे solve कर सकते हैं. A variable called pq of y square is equal to 4x. A variable called pq of y square is equal to 4x. A variable called pq of y square is equal to 4x is drawn parallel to y is equal to x. If the parameter of capital P and capital Q if the parameter of capital P and capital Q is small p and small q, then find value of small p plus small q. And find the value of small p plus small q. Now, variable chord of parabola is parallel to y is equal to x. सबसे पहले, if the line is given as y is equal to x, I know that the slope is equal to 1. Now the chord is parallel to y is equal to x, and since the chord is parallel to y is equal to x, I know that the slope of the chord will also be m is equal to 1 because they are parallel. So now what I am going to write is slope of PQ is equal to slope of y is equal to x. Slope of PQ is equal to slope of y is equal to x. Therefore, see, I know that PQ are two parameters. So if I take PQ as any of the two parameters, 80 square comma 280, if I take any of the parameters, I will get 2 upon T1 plus T2 is equal to 1. Now how did I get 2 upon T1 plus T2? Now imagine this is the parabola. This is a parabola. This is any chord, not the focal chord, it is any chord. So I'll take PS AT1 square comma 2AT1, and this will become Q as AT2 square comma 2AT2. My slope of PQ will become 2AT2 minus 2AT1 upon AT2 square minus AT1 square. So if I take 2a common, this will become T2 minus T1 upon a into T2 minus T1 and T2 plus T1. This gets cancelled. T2 minus T1 gets cancelled. I have got 2 upon T1 plus T2, and iska slope is equal to y is equal to x ka slope, which is equal to 1, which we have written it here. Therefore, I will get T1 plus T2 is equal to 2, but the parameter is not in terms of P, not in terms of T, it is given in terms of P, and this is given in terms of Q. So in other words, I will write P plus Q is equal to 2. Did you guys understand this? Parameter is not T here. They have specifically mentioned that your parameter for capital P is small p, your parameter for capital Q is small q. Hence, I have got the value of P plus Q is equal to 2. Do you guys understand this? Please write this down. Start drawing your web. So now this is the equation of tangent. This is your vertex 0, 0. This is your directrix, that is x is equal to minus a. This is your focus a, 0. It is a point on the parabola, that is 80 square, 280. This is m is the perpendicular. सबसे पहले पार्ट, can anyone tell me what will be SP का value? How will I find SP का value? How can I solve SP? I can solve SP by distance formula. So if I solve SP by distance formula, it will become under root of a minus 80 square the whole square minus 0 minus 280 the whole square, which will become what? A square plus a square t raised to 4 minus 2a square t square plus 4a square t square. What will this become? What will this become? A plus 80 square the whole square, which will become what? A plus 80 square. So I know the value of SP is A plus 80 square. Can you tell me what is the value of PM? What is the value of PM? By focus directrix property, SP is equal to? By focus directrix property, SP is equal to? What is the focus directrix property? SP is equal to? EPM. For a parabola, E is equal to 1. So SP is equal to? PM. So what is PM ka value? A plus 80 square. T is a point on the x-axis. T is a tangent. Since the tangent is cutting the x-axis, my y-coordinate is going to be 0. If I put y as 0, what is x ka value?
X plus 80.
What is x ka value? Minus 80 square. So now, what is ST ka value? What is OT ka value? 80 square. So what is ST ka value? A plus 80 square. So if we check SP, PM, ST has the same value. Now, this is a tangent, okay? This is a tangent. From the tangent, I will draw a normal. From the tangent, I will draw a normal, which is basically nothing but the perpendicular to the tangent. Now, I have the equation of the tangent at yt is equal to x plus at square. I have the equation of tangent as yt is equal to x plus at square. Now, can you tell me what will be the slope of the normal? I have the equation of tangent. I have the equation of tangent. My equation of tangent is yt is equal to x plus at square. My equation of tangent is yt is equal to x plus at square. What will I get from this equation? Can I get the slope? What is slope? Slope will become 1 by t. Now for a normal, my slope will become minus t, and I have the point as 80 square, 280. So by slope point form, y minus 280 is equal to minus t into x minus at square. So y minus 280 is equal to minus xt plus at cube. तो y is equal to 280 minus xt plus 8t cube. This is the equation of normal. So my equation of normal is nothing but, if I write in terms of, do one thing for your convenience, just write in terms of the positive values. So y plus tx is equal to 280 plus 80 cube. It becomes easier for you to understand this also. So my equation of tangent is y plus tx is equal to 280 plus 80 cube. What's going on? Now, this line, if we meet at a point n, it means that it touches the x-axis. इसको नहीं काम करना, हम इसको point G ले लेंगे. So now for here, if this coordinate, my y coordinate is 0, my y coordinate is 0, so my x coordinate will become 80 my x coordinate will become 2a plus 80 square comma 0. 2a plus 80 square comma 0, and therefore my s g का value, my OG का value is 2a plus 80 square. So can anyone tell me what will be my SG का value? It will become a plus 80 square, because if this is a and this is the entire 2a, this small part is nothing but a plus 80 square. So according to that, SP, PM, ST and SG, they all four have the same value. SP, PM, ST and SG, they all have the same value, that is a plus 80 square, and SG, they all have the same value, that is a plus 80 square, that is a plus 80 square. Okay, now this is the most important part. This is the tangent, y t is equal to x plus 80 square, and my normal is y plus tx is equal to 280 plus 80 cube. Anybody has any doubts here? Has everybody understood this till here? Please write this. Tangent drawn at P cuts the axis at T tangent drawn at P cuts the axis at T and normal at P cuts the axis at N. Find the locus of centroid. Find the locus of centroid of triangle PTN. Find the locus of centroid of triangle PTN. Full stop. If your answer is a parabola, then find the vertex. If your answer is a parabola, then find the vertex, comma, directrix, comma, LLR, length of lattice rectum, comma, LLR. Now, everything is given in this diagram. Everything, each and everything is given in this diagram. Okay, we have t ka value, we have p ka value, we have everything. So p is nothing but 80 square comma 280. This will become minus 80 square comma 0, and will become 2a plus 80 square comma 0. Okay, and will become 2a comma plus 80 square comma 0. The equation is yt is equal to x plus 80 square, y plus tx is equal to 280 plus 80 cube. Equation of normal is also given to me. Okay, now I have p ka coordinates, I have t ka coordinates, I have n ka coordinates. I'll take, let the centroid be g h comma k. So h ka coordinates will become 80 square minus 80 square plus 2a plus 80 square upon 3. 2a plus 80 square upon 3. Okay, this gets cancelled. I am left with 3h minus 2a upon a is equal to t square. This is what I have got, first part, h ka value. Now I will take k. K is equal to 280 plus 0 plus 0 upon 3. 3k upon 2a is equal to t. Therefore, if I square this, 9k square upon 4a square is equal to t square. Now I'll compare both the t squares. Therefore, I will get 3h minus 2a upon a is equal to 9k square upon 4a square. Okay, I'll cancel this a, I'll cancel this a. I will get 12ah minus 8a square upon 9 is equal to k square. So last में k square is equal to, I will take 12a by 9 outside. I will get h minus 12 no ठीक है 12 कॉमन आ गया. So if I take 12 common outside, I will get 2 by 3 a, and therefore my locus is y square is equal to 4a by 3 into x minus 2a by 3, and I get to know that the locus is nothing but a parabola. Therefore this is the parabola. अभी देख के मालूम पड़ रहा है. सबसे पहले they have said that if it is a parabola, सबसे पहले find the vertex. Now if I have to find the vertex, depending on the data we come to know that vertex is nothing but y minus 0 the whole square is equal to 4a into x minus 2a. So vertex will become, what is always like this, y minus beta the whole square is equal to 4a into x minus alpha the whole square, where alpha and beta is your vertex. If I take the vertex as alpha comma beta, now if I compare this here, so my alpha is nothing but 2a by 3 and my beta is equal to 0. So therefore my vertex is 2a by 3 comma 0. So I have got my vertex. Now 4a is your lattice rectum, and they have also asked what is the length of lattice rectum. So I know that length of lattice rectum is 4a. So मुझे पता है कि अगर 4a तो है ही, तो basically if I have to find out an equation of parabola क्या दिया है, y square is equal to, नहीं, we have got, this is the equation of parabola. They have said that find the vertex, हाँ find the directrix बोला है. Now if I find the directrix, second part we'll just find the directrix first. Directrix is x is equal to minus a. Here x is not x. This is x minus 2a by 3 is equal to minus a. X is equal to minus 2 by 3 minus 2 by 3 is equal to minus a by 3a. Okay, therefore x will become minus 2a by 3 is equal to minus a by 3, and I come to know that x is nothing but a by 3. This is your directrix. So I've got the vertex, I've got the directrix, and the last part they're asking is find the length of lattice rectum. अब length of lattice rectum तो ये देखिए मालूम पड़ रहा है. Length of lattice rectum is equal to 4a by 3 because this is the equation of parabola. 4a की जगह it's 4a by 3, so length of lattice rectum is 4a by 3. Did you guys understand this?